Here are your solutions. You know that you should do it first, right? And then try your best. You can fast forward to whatever question you need. Write out the first 5 terms. It is a sum. So I'm going to plug in 1, and then I'm going to plug in 2. So 2 times 2, take away 1 times 2, that's 6. Plug in 3, that's 10. I see a pattern here. And so I'm just going to, once I see the pattern, I'm going to follow it out. I don't have to add that. Same thing here. We're adding here. So we're going to plug in 1. That's 4 to the exponent 1. And then 2. And then 3. And I'm just plugging these in. That's 27 plus 4. 4. Is it 256? 3 to the 4 plus 4. One more time. 5. 625. No, 10. 4 to the 5 is 1024. 3 to the 5 plus 4, 247. The given pattern is here. Write the rule for this pattern. So this, we're adding 4 every time. So the pattern is 4, n minus 1 minus 2. Here we're multiplying by 2. So it's a1 and then times 2 to the exponent n minus 1. The number of students in a school year is estimated to be this model, but how many are in the school the first 3 years? So you plug in what A1 is, and then you get an answer. Plug in what A2 is, get an answer. Plug in A3 and get an answer. So you plug in 1, plug in 2, plug in 3, and you get your answers. During a 5-year period, a company doubles the profits every year. If the profits at the end of the 5th year are 176,000, then how about the previous 4 years? So if I was going forward, you'd keep doubling. But if I need to go backwards, I go half of what I see. So that would be 88,000, and then half again, and then half again, and then half again. So those are the last 4 years, year 4, 3, 2, 1. So the sequence is defined recursively, right? The first four terms. So A1 is 6, then we're going to multiply by 4, then we're going to multiply by 4, then we're going to multiply by 4. I think that's right, 96. $384. A1 is 2. And then it says multiply it by 2 and add 5. So 2 times 2 is 4 plus 5, that's 9. Then 2 times 9 is 18 plus 5. And then 2 times 23, that's 46 plus 5. And there it is. This one's the tricky one. So the first 2 terms are given, which are 1 and 5. Sorry, 2 and 5. And then what it tells you to do is take 2 terms back, which is 2, and then subtract 3 times 1 term back. So it's going to be 2 subtract 3 times 5. And we're going to do that again. We're going to go 5 subtract 3 times negative 13. So if I want to find the next term, I go 2 terms back, that's 5, subtract 3, and then times 1 term back, and then add, that's 39 plus 5, and you have the answer. These I need to expand, so I plug in 1, I plug in 2, I plug in 3, I plug in 4, and I plug in 5, and then I add these up, and it does add up to 45. Here, k plus 1 is in the exponent. So when I plug in 0, it's 0 plus 1, which is 1, so it's 1/5. Then when I plug in 1, it's 1 plus 1, which is 2, so it's 1 over 25. When I plug in 2, 2 plus 1 is 3, and 5 cubed is 125. Then I plug in, oh, that's it, right? No. Then I plug in 3. 3 plus 1 is 4. 5 to the 4. That's 625. And then add this up. You use your calculator and you get this answer. Plug 1 in, 1 plus 1 and then square it. Plug 2, 2 plus 1 and square. 3 plus 1 is 4 and square. 4 plus 1 is 5 and square. And then add that up and you get 54. Again, it's best that you try it first. So press pause and try it if you haven't already. Use sum notation. So it's going to go 1, and I don't know what how many terms there are, but I do know the rule. So we're adding 3 every time, and the first term is 3, so I know that. So on the side, I actually have to figure out how many terms there are. So I'm going to use the sequence formula, right? And I'm going to take it and make it equal to 18. So I want to know what term number 18 is. I'm going to solve it. So I'm going to subtract 3 and divide by 3. So 18 take away 3 is 15. 15 divided by 3 is 5. And then add 1. And so you can see this is 6. And then actually add it. So we have a formula for that to add it up. So we take the number of terms, 6 divided by 2. And then the first plus the last to get the answer. So that's what? 3 times 21. 63. All right, the 12th term of the sequence. So I need a rule. So write the rule. So I need a rule. So we're subtracting 5. And the first term is negative 10. And then to find the 12th term, you plug 12 in. So it's negative 5. 12 take away 1, which is 11. Take away 2, 10. So that's negative 65. Ah. Number 15, write a rule for it. Again, press pause and try it if you haven't. So we're adding 3, and the first term is 0. I don't need to go plus 0. And then the 9th term is 9 take away 1, so it's 24. 9 take away 1 is 8. It's just easier to calculate. All right, write a rule for this. You're given the 10th term and the 13th term. So to find the common difference, I'm going to go negative 48, subtract negative 18, and I'm going to go 13, take away 10. So that's negative 30 over 3, which is negative 10. And it says find the arithmetic means. So we have negative 18. There are 2, and then negative 48. So I'm looking for, between the 10th and the 13th, I'm looking for these two terms. So I'm going to subtract 10 and subtract 10. And those are my arithmetic means, the numbers in between what I'm given. Next one, same thing. I need to find the common difference by using the slope formula. Negative 110, subtract negative 54, and 16 take away 9. Get negative 56 over 7, which is negative 8. So we have negative 54, and we got 10, 11, 12, 13, 14, 15, and then 16. So it's all of those numbers in between. So we're going to keep subtracting 8. Let's see if I can do it. If I can keep subtracting 8 without making a mistake. I think I did it. You have your numbers. So those are the arithmetic means in between the two numbers that you're given. One more time. So we have 113 subtract 68 and 14 take away 9. That's 45 take away 5, which is 15. No, sorry, 45 divided by 5 is 9. And then The ninth term is 68, so 10, 11, 12, 13, and then 14 is 113. Keep adding 9. Let's see if I can do that. 77, 86, 95, 104. Did it. So put a box around it. Those are the arithmetic means. All right, we're just asked to find the sum. So we need to recognize, is it arithmetic or geometric? So we're adding 2 every time. So I need to know how many terms there are. I don't know how many terms there are, so we're going to do that first. So we're going to do a sequence, d n minus 1 plus 2, and make it equal to 336 and then solve it. So we're going to subtract 2, and then we're going to divide by 2 and then add 1. So 334 divided by 2. That's 167. And then if you add 1, that means we have 168 terms. All right, now I have everything I need. So I'm going to add the first 168 terms. So it's 168 divided by 2. The first term is 2, and the last term is 336. And then if we put it together, I get 28,392 with your calculator. All right, try the next one. Then press play. So again, I'm going to set up a sequence equal to that so I know how many terms there are. So the common difference is 2, and the first term is 1. And then I'm going to solve this. So I'm going to subtract 1 and divide by 2. And then add 1 after that. That's 612, right? And if I add 1, we have 613 terms. So the formula for 613 terms is 613 divided by 2. The first term plus the last term. And I get 375,769. All right, try the next one. The next one is in sum or summation notation or sigma notation. This is the easiest. There are 50 terms, so it's 50 divided by 2. To find the first term, plug in 1. So 4 times 1, take away 7. To find the last term, you plug in 50. 4 times 50 is 200. Take away 7 is 193. And then use your calculator, and you get your answer. Number 22, again, it's best if you try it first. A theater has 24 rows. That's n. First row has 20 seats. And then the next row has 23, and so on, and 26. So there's a common difference of 3. The question is, how many seats are in the theater? So one thing I need to know that I don't know yet is how many seats are in the last row. So we're going to do a sequence for that. So the formula for the sequence would be the common difference and then n minus 1 plus 20. And then I'm going to plug in 24 to see how many seats are in the last row. So when I plug in 24, there's 89 seats in the last row. Then the formula to add up 24 rows would be 24 divided by 2. We have 20 seats in the first row and 89 in the last row. And then calculate it, and you have 1,308 seats in total. Turn the page. A brick staircase has a total of 16 steps. Whoops. That tells you what n is. The bottom step, which can be A1, is 103. And then each one goes 4 less, so that's going to be negative 4. How many bricks are required to build the staircase? So again, we need a sequence formula. And I need to find how many bricks are in the last row. So the sequence would be negative 4, and it would be n minus 1 plus 103. And that will tell me how many bricks are in the last row. So calculate that, and you get 43 bricks. And then we add it up. So we're going to add up every step. So 16 divided by 2. We have 103 bricks in the first one and 43 in the last one. And then calculate. And you get 1,168 bricks. Suppose you receive a job offer. Again, it's best to press pause and try it first. But here's the support. With a starting salary of $37,000. That's A1. And you get a raise of $1,500 a year. That's D. How many years until you made a total that's aggregate of that. So if you add it all up, you get this. And now we set up an equation. So the formula for Sn, I'll show you remember the formula, and then we're going to plug in after the formula. So there's the formula we're going to use. Now you're told this, so I'm going to plug it in. Your 1,025,000 there. N, I don't know. And then A1 is 37,000. AN, we don't know what AN is, so we need to know the sequence formula for AN. So the sequence formula is 1,500 n minus 1 plus 37,000. You're then going to use your calculator. Now use X instead of N. You're going to go F1, you're going to go solve. Type it all in. You need comma X and then close it at the end. And if you solved it, you should get 20. Oh, sorry, 10. A local civic theater has 22 seats. In the first row, 21 rows in all. Each row has 3 additional seats. How many seats are in the theater? We need to know how many seats are in the last row. So we have 21 rows. So I first need to do that. So how many are in that last row? So plug into the sequence formula. 3 times n minus 1 plus 22. And then plug in 21 for n. Oh, let me calculate that. What is that, 60 plus 22? Is that 82? So we add them up. So it's going to be 21 divided by 2, and then 22 in the first row and 82 in the last. And you should get the answer 1,092 seats. All right, number 26. Write a rule for the sequence below. So the rule, are we adding or multiplying? And we're multiplying by 2. So the rule is 2 to the exponent n minus 1. The 12th term, we plug in 12. 12 take away 1 is 11. So it's 3 times 2 to the 11. I get 6,144. Here, again, we're multiplying. I think it's easiest to look at the first 2 and divide. So negative 3/4 divided by 3. That's like negative 3/4 times 1/3. Notice how the 3's divide out, and you're left with negative 1/4. So the common ratio, we're multiplying every time, is negative 1/4. So the sequence formula would be 3 negative 1/4 to the exponent n minus 1. And then the 12th term, you would plug 12 in. So again, it would be 12 take away 1, which is 11. If you had a fraction, it's a healthy number on the bottom. And there's the answer. If you had a decimal, it would be negative 0.00 tons of 0715. Okay. A new piece of equipment costs $68,000. That's A1. For tax purposes, the company depreciates, means it goes down in value by 25%. So because it goes down in value, I'm going to go 1 subtract. And what value should the company give after 8 years? So I want to know the 8th term. So A1 and then R is 0.75, because 1 take away 0.25 is that. And then the exponent 8 minus 1. And I get 9,076. It rounds to actually $9,077. All right, a particular substance decays in such a way that it loses half. That means R is 1/2 each day. How much of the substance is left after 10 days if it starts out at 256 grams? So we're not adding. We just, like, each sequence tells you each term how much is left. So we have a1 r to the exponent n minus 1. And then after 10 days, we plug in 10. 10 take away 1 is 9. And if you calculate it, you're left with 0.5 or half a gram if you put that in your calculator. Turn the page. A bicycle wheel rotates 400 times a minute. As long as the rider's pedaling. If the rider stops, the wheel starts to slow down. Each minute will rotate only 3/4 as many. How many times will the wheel rotate in the 4th minute? So we're going to model it. And then we're going to plug in 4. You can't do the work if you don't have the formulas memorized. So 4 take away 1 is 3. Then we put that in our calculator. And you get 169 times. All right, try 31 or not. You can just get support. Pendulum bob swings through an arc of 50 inches long. That's A1. Each swing, it swings only 86% as far as the previous one. What is the length of the arc after 11 swings? So I'm going to model it. So it's AN equals A1 times R to the exponent n minus 1. Then I'm going to find the 11th one. 11 take away 1 is 10. And you get like 11.06 or 11.07. That's inches. A football player signs a contract with a starting salary of $890,000. Annual increase. So if it's an increase, we're going to add 0.04, so it's 1.04. What will the athlete's salary be in the 6th year? So n is equal to 6. We're going to model it. So AN is equal to A1, 890,000. R is 1.04. And then to the exponent n minus 1, there's the model. And then plug in 6 and use your calculator. So 6 take away 1 is 5. And then calculate it, I get $1,082,821. Again, if you're just copying the video, this is not going to help you be more successful on the exam, right? So you have to actually put good effort first, press play, and then when you know what you're doing, press pause again and finish it on your own first. Then watch the video to see if you did it right. Marina takes a job with a starting salary of $39,000. That's A1. And an annual increase. So that increase, we're going to go 1 plus 0.055. So that's 1.055. And what is Marina's salary in the 6th year? So that's n is equal to 6. We're going to model it. So A1 R, which is 1.055 to the exponent n minus 1, and then plug in 6 and get our answer. Use your calculator. Press pause, see if you can try it. I know that 6 take away 1 is 5, so it's easier just to type that in. And it's $50,971. All right, now we're going to do some adding. So the formula to add, we need to know A1. So I'm going to plug 1 in. 4 to the 1 is 4 times 2 is 8. And then it's 1 subtract. The R is the base, which is 4. To the exponent, how many terms you have. And then 1 minus R on the bottom. Type that in your calculator, and you get 2,728. We're going to do it again. So we're going to plug in 1. 1 take away 1 is 0. Negative 3 to the 0 is 1. See if we can get this focused. And then 1 times 1/3 is 1/3, so 1/3. And then 1 minus negative 3 to the 13 over 1 minus negative 3. And you get 33,215.083 as an answer. Go for it and try. Turn the page. Our last page. A small business owner made $30,000 the first year. That's A1. Again, you should try it. Press pause. And made an additional 9%. So the R is 1 plus 0.09 or 1.09. Find how much he made during the fourth year if the total earnings during the first 4 years, and then round if necessary. So we have two questions. So the first question is, I'm going to model it. That's 30,000, 1.09 to the exponent n minus 1. So the fourth year is this. When I plug in 4, 4 take away 1 is 3, so that's what I'm going to type in. That's $38,850.87. Practice. And then the second one is adding. So if I want to add up all the first 4 years, the formula is A1, 1 minus R to the exponent 4 over 1 minus R. And then type that in. Again, you should press pause and try it first. And there's the total earnings. All right, Sunny improves her algebra skills, takes 0.8 times as long to complete each homework assignment as she took to complete the previous one. It means it takes less time. It took her 60 minutes to do the first one, and the rate is 0.8. Find how long it takes to do the fifth one. So we're going to model it, and then the total time. So the model is A1R to the exponent n minus 1. Then I plug in 5 to see how long it takes for the fifth assignment. So 5 take away 1 is 4. So 60 times 0.8 to the 4. That's 25 minutes about. The second question is add up the first 5, how long it would take. So that's a different formula. So that's going to be A1 and then 1 minus R to the exponent 5 over 1 minus R. So this is the best way to remember the formulas, right? Just practice it in questions. Type that in a calculator and you get 202 minutes total. Number 38. Press pause, you can try it. Initially, a pendulum swings an arc of 3 feet. That's A1. And then each one is 0.8 of the previous length, and then 10 swings. What's the total length with the pendulum have swung after 10 swings? So this is, we're adding, because of the word total. We're going to go A1, 1 minus 0.8 to the 10 over 1 minus 0.8. Know the formula, use it, and you get about 14 feet if you round it. Joytown sounds like a happy place. Has a present population of 40,000. It's A1. It's increasing, so we're going to go 1 plus 0.025. How long will it take for the population to double? So that means our end is 80,000. We're not adding every year, just each one is what the population is. So we're going to model it. Then I'm going to plug in 80,000. And then use your calculator. Otherwise, you'd need a logarithm, but use your calculator to then solve it, and you get about 29 years for it to double. All right, determine the infinite series. Does it converge or diverge? So R here, if I go 1 divided by 2, it's 1/2. That means it converges. And we have a formula, which is A1 over 1 minus R. So this converges to 4. Here, again, divide. I get negative 1/3. That's between negative 1 and 3. It converges. So A1 over 1 minus negative 1/3. That's the same as adding. 1 plus 2/3. Get common denominators, and you get 5 over 3. Multiply times the reciprocal, and you get 9 over 5. That's what it converges to. Oh, why did it change to 2/3? 1/3. So if I add it, it's 4. So that means this is 4, which is 12 over 5. Which this is 4. So it's 9 over 4. Jeez, willikers. There it is. This is 3 times 3/4. That's what I'm doing. Should have been a 4. Divide. Now, I'm not going to go 18 divided by 54. I'm going to go 2 divided by 6. That's 1/3. And then the formula is A1, and then 1 subtract the common ratio. That's 2/3. See if I can do this one right. We multiply times the reciprocal, and then get our answer. So whatever that is. What is that? It's 27 times 3. 60 is 81. Done. Okay, last page. All right, a pendulum swings through an arc of 40 inches to begin with. That's A1. Each swing thereafter only 70%. How far will it swing altogether before it stopped? So that's like going to infinity. So the formula is A1 over 1 minus R. So that is 40 over 1 minus 0.7. And that's 133 swings. You can use your calculator for that one. Use your calculator for everyone. A ball, this one was a little tricky. I was talking to a student about this one. I won't say who. And it took me a while to make sure I explained it correctly and I did it correctly. So it was really good that we did that conversation and try to figure it out. So a ball is dropped from a height of 25 feet. So here we are at 25 feet, and here's the ground. So at 25 feet, the ball is dropped. It then bounces up, and it says to 0.7 of the previous height. The total distance the ball traveled, the second bounce, is this. So for the second bounce, I need to plug in 1 and figure that out. So I'm going to multiply that out. So I'm going to plug in 1. So it's 20, or just figure it out. So 25 plus 2 times 25 times 0.7. And you get 60. So the bounce is up here, so you drop it, and then, so it has a big bounce to it. So one of those super balls. So it bounces, but it bounces super high, and then the next time when it comes down, it then goes up to 0.7 of that. So then you would plug in, 2 and then 3 and so on. So we're going to use this to figure out how many bounces there are in terms of to infinity. So we're going to go 25 plus, and then we're going to use this geometrically. So if I plug in 1, 50 times 0.7 times 1, try it again, 50 times 0.7, and you get 35. So I'm just going to use this. So plug 1 in, so A1 is 35, and then 1 minus the rate, which is 0.7, and I'm just going to use my calculator for that. And I get 141.667. That's what I get. All right, we're going to move on. 2 more. A ping pong ball is dropped at 9 feet and always rebounds 1/3 of the distance. Find the total sum of the rebound heights. So the rebound, the bouncing heights, A1 is 9. The rebound is 1/3 of the distance. So this is the formula we're going to use. So that's 9. 1 take away 1/3 is 2/3. So that's 27 divided by 2, or what would that be? 13.5 feet being the total. All right, one more. After being struck with a hammer, a gong vibrates 72. That's A1. And then the R is 6/7. And then how many vibrations until it stops? So like to infinity, how many vibrations is that? So it's A1 over 1 minus R, and then times the reciprocal, 72 times 7, 504. And you did it. Hey, great job working through this study guide. I hope it helped, and good luck on the exam. Mr. G Math, over and out. Until next time.